Hello, this is Miraj Patel, and today we're going to start Unit 4, which is about the periodic table. And today we're going to specifically talk about how the periodic table is created and periods of the periodic table in groups. So the first PowerPoint here I have is about the history of the periodic table. And so, like with most people, it's so much easier to organize a bunch of random stuff by grouping it into categories. So that was the same thing with elements. So back in the 1700s, early chemists used properties of elements to organize them into little groups called, or triads. That the little groups were called triads. And so here's an example of a triad. There was chlorine, bromine, and iodine. And so because they had similar properties, they just put them into groups. And then in 1864, there were 56 elements, and Newlands and Meyer arranged them in by atomic mass. So then they noticed similar properties, so they also grouped them up into similar properties. And then Dmitri Mendeleev got an idea from his favorite card game, Solitaire, and he organized the elements by increasing atomic mass and similar properties. So he was the guy that decided to organize them by numerically, by increasing atomic mass. And he also grouped them by similar properties like the other scientists have been doing. And then the cool part about his trick was that he could predict properties of undiscovered elements based off of just their organization of this chart. So, in fact, he predicted the properties of gallium, and they seemed very accurate. So let's just go through this chart. So Mendeleev predicted that the atomic mass would be 68, and it was 69.7, pretty close. He predicted the density to be 6 grams per centimeter cubed, and it was 5.9, which is super close. He predicted that it would be a soft gray metal, and it was in fact a soft gray metal, and he predicted a low melting point, and it does have a low melting point. And here's a picture of gallium to show how it looks. And then we have one more scientist that contributed to the periodic table's organization, and that is Moseley. And Moseley arranged the elements by the newly discovered atomic number, and so he arranged it in increasing atomic number order. And so here are some important terms to know about the periodic table. A period is a whole row across the periodic table, and one period, or each period, is an energy level. So if you remember about the Bohr model and how each ring around the nucleus is an energy level, there's a rule about the number of electrons you can put in each energy level, and so each period tells us how many electrons we can put on each ring. So if you remember in the Bohr model, the first ring could only have two electrons, and the periodic table shows us that because there's only 2 elements in the first period. Then on the second ring we could put 8, and again the periodic table tells us that we can put 8 electrons because there's 8 boxes. And then third we can put 8 too because there's 8 boxes. And then the fourth ring we can put 18, and so on and so forth. And so each period tells us how many electrons we can put on a Bohr model. So it tells us how many electrons are in each energy level. Then we have vertical columns, which are groups, and it's important to know that groups have similar properties, and we'll talk more about that later on in this unit. And so the modern periodic table arranges elements by increasing atomic number, and that was Moseley who decided to organize it like this. And periodic law is the idea that there will be repetition of properties, or periodic repetition. That's why it's called the periodic table, and I'll explain in a moment. And so properties change across the period. So once we move down the rows, we change properties, and then properties repeat from period to period. So in period 1, we have 2 properties, and then in period 2, these properties will repeat, and same thing. So let's just do an example and show you this. So because groups have similar properties, so these vertical columns have similar properties, that means once we reach the end and we go back down, we'll be going through similar groups or the same groups, and we'll repeat properties. So for example, we have group A here, B here, and then C here. And so as we go down, we do A, B, C, and then all these, and then we go back down again, and then we reach A, B, C again. So pretty much, because there's groups that have similar properties, when we go across, we change properties, but once we restart on the next period, we repeat the same properties. And there's 3 classes of elements, which are metals, which make up most of the elements. Then there's nonmetals and metalloids. And metalloids makes up a small category, which is only this little strip. These are all the metals, and then the nonmetals are mostly over here except hydrogen, which is all the way over here by itself. And the periodic table is organized so the most metallic elements are on the left and the least metallic are on the right. And here's some important properties of each of the classes. So metals are pretty much shiny. They are malleable, so they can be made into sheets. They're ductile, so they can be made into wires, and they're good conductors of both heat and electricity. So that is why it's pretty often that there's metal in wires, because metals do a good job at conducting electricity, so electricity can easily pass through it. And nonmetals are mostly gases at room temperature, so like oxygen, carbon, nitrogen, neon, helium, so those are all gases at room temperature. Well, most of them are. And then they're brittle solids, so if they are solids, they're very brittle, so they break easily. Like above, this is sulfur, and it's all broken up. They're poor conductors, and so pretty much they don't really like to have heat or electricity pass through it well. Then there are metalloids, which are dull or shiny. Well, this metalloid above is pretty shiny, so they can be either dull or shiny. And they're very brittle, so they break easily. And they're semiconductors, like in computer chips and stuff, like silicon. These are semiconductors, so they sort of conduct electricity, but not fully like metals, but not too poor like non-metal, so they're in the middle. One quick quiz. So here's a quick quiz to see what you learned. Mendeleev arranged his elements in his periodic table in order of increasing blank and by blank properties. So A, atomic number, and then similar. B, number of protons and repeating. C, a number of electrons similar. Or D, atomic mass repeating. So Mendeleev, the important part was he arranged it by increasing atomic mass, because atomic number was not discovered at his time. So he only knew about atomic mass, and he grouped them up by similar properties or repeating. So the only answer with atomic mass is D. So just by looking at the first blank, you can eliminate A, B, and C, because pretty much the number of protons and number of electrons is atomic number. So these are practically all the same. And so the answer is D, and repeating still fits because repeating and similar are pretty much synonyms. And here's question 2. The modern periodic table is arranged by increasing A, mass number, B, density, C, atomic number, or D, intelligence. You can eliminate B and D because D is just ridiculous, and there's nothing really about density on the periodic table. And when you look on your periodic table, you see the elements are arranged from 1, 2, 3, 4, 5, 6, and that is the atomic number. So it is a ramified increasing atomic number. And if you remember, the mass number is that weird decimal at the bottom, and it doesn't necessarily have to be increasing, but it could. It could be increasing because if you increase the atomic number, you increase the number of protons, which affects the mass. But the correct answer is C, atomic number, because that's what it's meant to be. Question 3. Elements in the same group have very little in common. A. B. The same atomic number. C. Different chemical properties. Or D. Similar chemical properties. So a group is a vertical column, and if you remember, groups have very similar properties, and it's because they have the similar number of valence electrons, and so we have to look for answers that say very similar, or very similar, or very much in common. So A is out, B is out, because if they're the same atomic number, they're the same exact element, so that's not true, because they're different elements. Then C, different chemical properties. No, that doesn't say that they're similar, so the answer is D. They have similar chemical properties. Because those valence electrons on the outer energy level. Which of the following is not a general property of metals? A. Ductility, B. Malleability, C. High luster, or D. Poor conductors of heat and electricity. So metals, let's just go through all the properties of metals. Metals can be made into wires, or they're ductile, so A is out. B, they're malleable. Metals are able to be bent into sheets, so they are malleable, and so B is out. And then C, metals are shiny, so C is out. And D, they are not poor conductors, so D is the answer. And if you just remember from your household that metals are used in wires, and wires have electricity, so metals are used in wires because they conduct electricity well, and metals are used for pans and cooking ware because they conduct heat super well. And so if metals weren't good conductors, why would we have it in wires or in pans? So sometimes you could use your common sense to answer these questions. So just keep in mind to use your everyday experience to sometimes answer these questions. And so which list of elements contains only nonmetals? So let's just go through each row, and once you see anything that is not a nonmetal, then you can eliminate the whole answer. So for the first one, SN, P, and Cl. Cl is chlorine, P is phosphorus, and then SN is actually tin. So tin is a metal, we know that from looking at the periodic table. So you can eliminate A because tin is a metal. And then B, S, Na, and O. So S is sulfur, Na is sodium, so sodium is a metal, so you can eliminate B. Then let's go to C. Ge immediately is germanium, which is a metalloid, so you can eliminate C. So the answer is D. And just to check, O is oxygen, non-metal, I is iodine, non-metal, and then H is hydrogen, which is definitely non-metal, so the answer is D. So let's identify each of these elements as a metal, non-metal, or metalloid. Copper, I'm sure most of you know, is a metal. Boron, if you look on the periodic table, it is a metalloid. Sulfur, most of you probably know from that annoying smell from sprinkler water, is a non-metal. Sodium is a metal. Tin, I'm sure most of you know about tin, and it's definitely metal. And then hydrogen is a non-metal. And here is our last question. Identify the following sample of an unknown substance as a metal, non-metal, or metalloid. It's solid at room temperature. It will break rather than bend, and conducts electricity only at high temperatures. So if it's solid at room temperature, you can sort of eliminate that it's a non-metal because most non-metals are gases at room temperature. So it would rather break than bend. So it's not a metal. And let's just check. Right now, I'm thinking that's a metalloid, and so let's just see if it corrects. If this last characteristic is of a metalloid, then we're pretty sure it's a metalloid. So it conducts electricity only at high temperatures. So metals conduct electricity mostly all the time, pretty much. Nonmetals don't conduct electricity at all, and metalloids are semiconductors, so they sometimes do, sometimes don't, or conduct electricity a little bit, not a lot or a little. So it's in the middle. So this does sound like a metalloid. And honestly, if I had to do this question quickly, I would just look at the last clue. And because it don't conducts electricity only at high temperatures, I would know that it's not a metal because metals conduct it all the time. No, it's not a nonmetal because nonmetals hardly conduct electricity or heat. So it had to be a metalloid. So just from looking at this last clue, you can sort of eliminate it just did down to metalloid. And so here's the next PowerPoint, which is about periodic groups. And so here we're going to talk about some groups and some chunks of the periodic table. So there's several main groups. There's the s orbital and then the p orbital. And these groups, so 1 to 2, and then 3a to 8a, these have a wide range of properties. There's metals, nonmetals, and there's some metalloids in here. Then there's the D block, which has a d orbital, and those are transition metals, and so those are like iron, tin, silver, gold, nickel. So those are some metals. And then we have the F block, which is called the inner transition metals, and these are all the weird elements like plutonium, uranium, americium, some weird ones like that. And next, what is the number one most significant factor that groups elements together? And this is valence electrons. And like we talked about, valence electrons is why elements have similar properties, and valence electrons are electrons on the highest occupied energy level. And so these are some Bohr models of several elements. And so the first one has one valence electron, the second one has two valence electrons, the third one has 7 valence electrons, and then the fourth one has 8 valence electrons. And these are the last little numbers of the electron configuration, so you can tell by the exponent the number of electrons, just as a little refresher. And so these are some elements on the periodic table, and then these are the elements underneath are from the corresponding group. And notice how they have the same number of valence electrons. So this one has one valence electron, this one also has one valence electron. And then the next element, magnesium, has the same number of valence electrons as the one above, beryllium. And then fluorine has the same number of valence electrons as chlorine, has 7 also. And then argon has 8 valence electrons, just like neon. So that is why they're organized in the same group, because they have the same number of valence electrons. And so here are some common unique groups. And so the first group is called the alkali metals, and they're group 1. So because they're in group 1, they have one valence electron, and you can see on these electron configurations they have the highest energy level has 1 as their exponent, so 1 energy level, 1 electron on their highest energy level. And these are soft metallic solids, and most reactive metals are at the bottom because they lose electrons the easiest. And here's a video to see how reactive.
Now let's see another reaction of the alkali metals, the reaction with water. We'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas.
And so this is
Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water in the same way. Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a light flame. The next element is rubidium. This time, we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our fifth alkali metal.
And so that shows you how when these elements, this one group, alkali metals, as we go down the group, it gets more and more reactive because they lose electrons the easiest as we go down. And then we have the second group, alkaline earth metals. So they have 2 valence electrons, and they're reactive metals like the alkali metals, and they're the most reactive as we go down because they lose 2 electrons fairly easier at the bottom than the top. And we'll talk more about this in the next video about why exactly is it more reactive as we go down. And then on the right side of the periodic table, in group 7A, we have the halogens, which includes fluorine, chlorine, bromine, iodine, and these elements have 7 valence electrons, and they're the most reactive nonmetals because they take one electron the easiest. And this is the opposite of the left side, so the top element is the most reactive than the bottom element. So fluorine is the most reactive out of all these. And then we have the last group, which is called the noble gases, and they have 8 valence electrons except for helium. Helium only needs 2 to fill up the valence shell. And so their valence shells are full, so they don't want to gain or lose any more electrons. And so that is why these gases are unreactive, because they have a full valence shell, so they don't want to exchange or gain or lose any electrons. And similar groups have similar chemical properties, and again, this all has to do with the number of valence electrons, because similar groups have the same number of valence electrons, they have similar properties. And here's a quick quiz to see what you learned. 1. Elements in a group in the periodic table, A, have the same mass, B, have similar properties, C, have the same atomic number, or D, have the same number of valence electrons. So in a group, which is a vertical column, elements have similar properties, that's definitely the answer, because they have the same number of valence electrons. So the answer is B and D, because they have the same number of valence electrons, they have similar properties. We can eliminate A and C because if they have the same mass, they are most likely similar elements, and they don't necessarily have to have the same mass. And they don't have the same atomic number because only the same element has the same atomic number, so that is definitely out. And let's move on to question 2. Alkali metals have how many valence electrons in the highest occupied energy level? A8, B1, C2, D3. So the alkali metals are column 1A, and because they're in column 1A, they only have 1 valence electron. And this was the one with the video with how reactive they are, and if you remember, as we go down the group, they're more reactive because they lose electrons the easiest. And so the alkali metals are the ones reactive with water. Noble gases, A, are the most reactive nonmetals, B, are the most reactive metals, C, have 8 valence electrons, D, are typically unreactive. Well, noble gases is column 8A, and because they have a full valence shell, they are not reactive at all. So you can omit A and B because these two answers say that they're very reactive. Then we can look at C and D, and so C, they have 8 valence electrons. That is true somewhat, except for helium, and they're typically unreactive. That is also true. So the answer is C and D, and because they have 8 valence electrons, they are unreactive. So one causes the other. And then here's another question. Which one of the following is incorrectly labeled? A, Ne, a noble gas, Cu, a transition metal, Sn, a nonmetal, or Cl, a halogen. So A, let's just go through all these. So starting with A, neon, a noble gas. Well, if you look on your periodic table, neon is in the last row for the 8A group, and the 8A group is also known as the noble gases, so it is correct. Then we looked at Cu, so copper is a transition metal because it's in the D block. It's number 29. And then let's look at D, so chlorine. So chlorine is in group 7A, which is also called the halogens group, and so D is correct. But C, Sn, which is tin, is a metal, so it's not a nonmetal. So C is incorrectly labeled. And question number 5, transition metals are characterized by having electrons in which orbitals? So let's just look at the periodic table. And so this is the S block, P block, D block, F block. And so which block is the transition metals? So that would be the D block. So the transition metals have D orbitals, so the answer is C, because they're in the D orbital. And so here's a quick overview of what we talked about in this video, second half. And so we have 4 main groups that we talked about. So we have the alkali metals, which are the metals that we looked at the video. And then we have the alkali earth metals. And then we have the halogens, which are like chlorine, fluorine, bromine, iodine. And then we have the inert elements, or the noble gases, and inert just means that they don't like to react, or they don't do anything. And these are gases like helium, argon, neon, and so then we have the D block here, which are the transition metals like iron, nickel, silver, so pretty much typical metals. And then we have some metals and metalloids, which aren't labeled here, which are in this border. And then we have the F block, which are the rare earth elements like uranium and plutonium. And so that is pretty much an overview of the organization of the periodic table. And that is it for today. The next video we'll be talking about periodic trends. So why do elements and groups react more strongly at the bottom versus the top, and we'll talk about electronegativity and stuff like shelling. And so I hope this helped you learn about the periodic table, how it's organized in some groups, and we'll see you next time.